Well, hi there, sports fans, and welcome to another exciting edition of Topics from the World of Physics 12. Today is lesson 1.3, and we are talking about acceleration today. Now, the topic that we're covering today is not that difficult. There's just a couple of tricky things that you have to be aware of in order to solve these kinds of problems correctly when you're dealing with acceleration. And if you get these right now, it'll go a long way in helping you deal with problems that have acceleration in them. So you want to really pay attention to some of the little details, the tricky little things that I will be talking about as we go along. First thing I'd like to do is talk about the units of acceleration. Now, I don't know about you, but when I was taking high school physics, the units of acceleration, meter per second squared, that didn't really say a whole lot to me. I didn't really quite grasp that. Meters per second? Like, well, what does that even mean? As we go along today, hopefully we will be developing the units here, and hopefully that will help you see, exactly what we mean by acceleration and where this kind of a unit does indeed come from, and it should start to make more sense to you. Now, let's start with a definition of acceleration. What do we mean by acceleration? Because we sometimes get that confused. And acceleration is just simply the change in velocity per unit of time for an object. So it's change in velocity per unit of time. In other words, it's how quickly an object's velocity changes. How quickly is an object's velocity changing? That's simply what acceleration is. And we tend to get it confused with some other things, which I will talk about as we're going along here. So we said acceleration is change in velocity divided by per unit of time. So change in velocity, we can use this symbol right here because the delta symbol means change in. So we can just write delta V, and again, it is velocity that we're talking about. So we need to use that vector symbol there. And it's per unit of time, which is in seconds. And again, time is not a vector, it is a scalar. That's why there is no vector symbol over top of the S here. So acceleration is indeed a vector, and over here, as you can see, we have the velocity symbol here with the vector indication over top of it. So that means that we are indeed talking about a vector because we're using velocity. So let's look at the units here then. How these units are going to work out. All right, well, if we're talking about velocity, we know the units of velocity are meters per second. So we can write that down. So meters per second. Okay, that's velocity, units of velocity. And the units of time are seconds. So we're going to divide by time. Divide by time, which is in seconds. So this is where the units are going to start, where acceleration is units of velocity divided by units of time. So let's expand this out a little bit, because we know that any time that we divide by something, we can just also multiply by its reciprocal, and that's what we're going to do. So that's meters per second. Now, instead of dividing by the S, I'm just going to write this instead, 1 over S. Okay, so this then becomes that there, where anytime you divide by something, you multiply by its reciprocal. So now we have meters per second times 1 over second, and as you can see, when you multiply that out, you get meters per second squared. And so that's where the units come from. Oh, and I wrote this over here because units of velocity are meters per second, and time is in seconds. All right, so if you look at it this way now, then you can see where the units come from, and hopefully they're not such a mystery for you, and hopefully I can save you a little bit of time in terms of just understanding where the units for acceleration actually come from. And it's really not that difficult. It just took me a little bit longer to sort of grasp the concept, but hopefully I can save you a little bit of time in that regard. So there's our units, and we've had our definition. It's the change of velocity per unit of time. there's a units meters per second squared. So let's look at some examples of things that do have velocity. First example I'd like to refer to is the drag race car. And drag race car, you're talking some serious acceleration here, where drag race cars are known to go from 0 to 300 miles per hour in less than 4 seconds in a quarter mile. And that's some serious acceleration. As you know, I'm a big race car fan, and so naturally I'm going to use this kind of an example. But yeah, drag race cars, lots of acceleration, 0 to 300 in less than 4 seconds in a quarter mile. However, compare that with the three-toed sloth. Not so much acceleration there. This three-toed sloth really doesn't get too excited about anything. They hang around in the treetops, the canopies, in the rainforest and such. And so they're really not too concerned about a whole lot. They very seldom ever have to, go from a standstill to top speed very often. And top speed is not that great to begin with. And so not a whole lot of acceleration happening with the three-toed sloth, unlike the drag race car. All right, usually we think of acceleration as speeding up. And quite often, in terms of our vocabulary, we kind of use the terms interchangeably. Acceleration, speeding up, or I should say we use the term acceleration in terms of just the motion of an object. But you've got to understand they're not quite the same thing. So I will hopefully be able to show you the slight differences between those things. But as far as acceleration goes, oftentimes we just think of acceleration as something is speeding up. However, when an object is slowing down, it is also accelerating. Why? Because its velocity is changing. If something is slowing down, its velocity has to be changing. Therefore, it is experiencing acceleration. It just happens to be that its acceleration is negative and not positive. That's all. But anytime that you have a change in velocity, whether it's speeding up or slowing down, then you have acceleration. And we just call it acceleration. Even though it's negative, we just call it acceleration. We don't need to worry about the term, deceleration or anything like that. We just recognize that slowing down is acceleration. It's just negative acceleration, that's all. Now, this is the most important concept to understand right now. First of all, anytime that you're dealing with a problem that involves motion and objects and things, and I will be talking about this all year, is that you want to have a diagram. Get yourself a diagram on paper, and if you've got that correct and you have all the information on your diagram that you need, you will be more than halfway towards solving your problem correctly. So get your diagram, get in the habit of starting with a diagram always. So that was the first thing. Now, the other is that, we have an object and it has velocity here, it's moving to the right, and so we can say that its motion, and this is something that you will want to include on your diagram, is indicate the direction of motion. That's a real important thing to have on your diagram. So generally speaking, it will be the same direction as your velocity, the velocity that you're given. The motion will be in that direction, but the velocity can change. And so we want to have on our diagrams what the direction of motion is with the information that we're given. And that's going to be extremely helpful to you. So let's say then that our object is accelerating this way, to the right, or east, as we sometimes say. And in this case here, if the acceleration is the same direction as the velocity, then obviously the object is going to be speeding up. So acceleration, velocity, same direction, object will speed up. On the other hand, if your acceleration is in the opposite direction of your velocity, then obviously the object will slow down. So again, this is where it's helpful to have the motion direction indication on there so that you can see right away, okay, well, there's my velocity. I'm moving this way, but I'm accelerating this way. So that means I'm slowing down. And if that acceleration were to continue, then what would happen is eventually the object will stop. And if the acceleration carries on further, then your object will change motion, change direction of motion, and accelerate into the opposite direction. So the motion that we have on our diagram is indeed the initial motion. All right. So as we're going along, we don't necessarily need to change the direction of the motion on our diagram, but we need to know what the motion is initially in order to know how the acceleration is affecting the object. Is it speeding it up? Is it slowing it down? And so that's where the motion indicator will be most useful to you. All right, so lastly, don't confuse acceleration with motion. And this is probably one of the most common mistakes initially when we're dealing with this, with this topic of acceleration. Don't confuse acceleration with motion, as I mentioned earlier. And so, again, if you have motion indicated, the direction of motion indicated on your diagram, that's going to be real helpful because you will understand that motion is different from acceleration. Acceleration is a change in velocity, and it's either positive or negative. Motion is just simply the direction that an object is moving in when you first start to analyze a problem. So this is one of the most important things to understand right now, and this is sort of your, I was about to say take-home message, but really this is your take-to-school message, is don't confuse acceleration with the direction of motion. And get your motion indication on your diagram right away, and then get your acceleration on there, and then you'll be able to analyze what's happening with this particular object. Now there's a couple other things as far as graphs and things that we'll look at in class, but until then, you can replay this video as many times as you want. If there's some little tricky things in there that you want to see again, and so by all means do that so that you fully understand this concept, because this is going to lay a foundation for a lot of the things that we're doing for the rest of the year.